Let us work a few more problems on limit of a sequence, because you have studied many theorems on limit of a sequence, convergent sequences, divergent sequences, and oscillatory sequences, and also geometric series, that is x power n. That sequence is convergent if and only if mod x is less than 1. If mod x is greater than 1, it is divergent. And if x is plus 1 and minus 1, then it is oscillatory. So using that theorem here, let us work few more problems. So first problem is, let xn be equal to 8 power n plus 1 plus 5 power n minus 1 whole divided by 2 power n plus 1 minus 8 power n minus 1. So our xn is 8 power n plus 1 plus 5 power n minus 1 whole divided by 2 power n plus 1 minus 8 power n minus 1. Let us evaluate the limit of the sequence, and finally we shall say whether it is convergent or divergent. Converges to what limit? That is also materialistic. Okay. First, you take 8 power n outside in the numerator. In the numerator, you take 8 power n. Remember, 8 power n plus 1 can be written as 8 power n into 8 power 1. 8 power n plus 1 can be written as 8 power n into 8 power 1. If you take 8 power n outside, you will get 8 power n into 8 plus 5 power n minus 5 power n minus 1 can be written as 5 power n divided by 5. Remember, 5 power n minus 1 can be written as 5 power n divided by 5. You are taking 8 power n outside, therefore in the denominator you will get 8 power n. So it is 8 power n into 8 plus 5 power n whole divided by 8 power n into 5 whole divided by, in the denominator also you take 8 power n outside. You will get 2 power n plus 1 can be written as 2 power n into 2 power 1 whole divided by 8 power n minus 8 power minus 1, because 8 power n is taken outside. Let us cancel 8 power n both in numerator and denominator, which we have taken outside, as a common factor here. That common factor term 8 power n can be cancelled. So if we cancel 8 power n, what we will get is 8 plus 1 by 5 into 5 power n by 8 power n can be written as 5 by 8 power n whole divided by 2 power n divided by 8 power n can be written as 2 by 8 to the power n into 2 minus 8 power minus 1 can be written as 1 by 8. 8 power minus 1 can be written as 1 by 8. Remember, 5 by 8. What is 5 by 8? The value, is it less than 1? Yes, because it is 0.66. 5 by 8 is 0.66. 0.66 is less than 1. If it is less than 1, there is one theorem. X power n is convergent if x value is less than 1. If mod x is less than 1, x power n is convergent, converges to 0. That is the theorem. Limit of x power n as n tends to infinity is 0 if mod x is less than 1. We have a theorem. Using that theorem, 5 by 8 value, that is less than 1, because 5 by 8 is nothing but 0.66. So 0.6, that is less than 1 here. Therefore, 5 by 8 power n as n tends to infinity is 0. According to that theorem, 5 by 8 whole power n as n tends to infinity is 0, because 5 by 8 is less than 1. So this is 8 plus 1 by 5 into 0, because 5 by 8 power n as n tends to infinity is 0 whole divided by 2 by 8. Is it less than 1? Yes. So 2 by 8 value, that is 1 by 4. 1 by 4 is nothing but what? 0.25. 0.25 is less than 1. Because it is less than 1, its power n whole as n tends to infinity is 0 according to that theorem. So I will get 0 into 2 minus 1 by 8. So if you simplify this, it is 8 divided by minus 1 by 8. Therefore, it is minus 64. Therefore, here the sequence xn is convergent. Converges to what limit? Minus 64. This problem was asked in the examination. Next, take another problem. So another problem is Let xn be equal to 1 square plus 2 square plus 3 square plus so on up to n square, whole divided by 1 cube plus 2 cube plus 3 cube plus so on up to n cube. This is our xn. Some of the squares of the natural numbers in the numerator, some of the cubes of the natural numbers in the denominator. So summation of the formula, you have a formula, 1 square plus 2 square plus 3 square plus n square is n into n plus 1 into 2n plus 1 divided by 6. This is the formula for sigma n square. So what is sigma n square? It is 1 square plus 2 square plus 3 square so on up to n square. Its formula is n into n plus 1 into 2n plus 1 divided by 6. Similarly, sum of the cube of natural numbers, you have a formula for this. So what is cube of the natural numbers? 1 cube plus 2 cube plus 3 cube plus so on up to n cube is n square into n plus 1 whole square divided by 4. You have a formula for sigma n cube. Sigma n cube is nothing but 1 cube plus 2 cube plus 3 cubes so on up to n cube. The formula for that is n square into n plus 1 whole square divided by 4. Next, in the numerator here, you have 3 n's. One n here is here, and another one is here, and another one is here. Take those n outside. So if you take these two n outside, you will get n into n into n. So it is n into n into n. If you take n outside here, you will get 1 plus 1 by n. If you take n outside here, you will get 2 plus 1 by n. Whole divided by, that 4 comes to the numerator, remember, 6 in the denominator. Here you will get, if you take n outside inside this ordinary bracket, if you take n outside, that becomes n cube here because n square is there. So n square into n square. It is n square into n square because you are taking n outside and square is there. You will get 1 plus 1 by n whole square. So this n cube and this n raised to 4, here you have n cube and here we have n raised to 4. Therefore, n cube cancels. You will get 1 n left in the denominator. And here in the numerator, 1 plus 1 by n, 2 plus 1 by n, divided by n into 1 plus 1 by n whole square, into 4 by 6 is nothing but 2 by 3. Now take as n tends to infinity. If you take n tends to infinity, 1 by infinity is 0. Similarly, 1 by infinity is 0. In the denominator also, 1 by infinity is 0. So this is 1 plus 2, 1 into 2, 2 into 2, that is 4, divided by, this term is 1 here because n is infinity, 1 by infinity is 0, 1 square is 1. If you put n equals infinity, so it is something in the denominator we have infinity. So something divided by infinity is nothing but what? 0, because 1 is left, 1 n is left in the denominator. As n tends to infinity, this is 1 by n. Therefore, you will get 0. So 1 by infinity, it is 0. So therefore, the limit of the sequence is 0. It is convergent here. The sequence, given sequence is convergent. Let us take another problem. Let xn be equal to log n divided by n. Verify whether this sequence is convergent or divergent. So log n by n can be done in 1 by n log n. This is log of n to the power 1 by n because m log a form. I think I worked this problem earlier. So therefore, limit of xn as n tends to infinity is n to the power 1 by n as n tends to infinity is 1. There is a theorem, of course. Limit of n to the power 1 by n as n tends to infinity is 1. Log 1 is 0. Therefore, we have a finite limit to 0 here. Therefore, the sequence xn is convergent. If you have a limit infinity, then the sequence is divergent. But here, in this problem, you have got only 0 here. Therefore, the sequence is convergent. Let us work some more problems now. So, sequence xn equals the square root of n square plus 1 minus square root of n square minus 1. We shall verify whether the sequence is convergent or divergent. For that, let sequence xn be equal to root of n square plus 1 minus root of n square minus 1. So what is our xn? That is root of n square plus 1 minus root of n square minus 1. Multiply both the numerator and denominator by the conjugate of this. In other words, multiply both numerator and denominator by root of n square plus 1 plus root of n square minus 1. you will get root of n square plus 1 minus root of n square minus 1 into root of n square plus 1 plus root of n square minus 1 whole divided by root of n square plus 1 plus root of n square minus 1. Remember, you are multiplying both numerator and denominator by square root of n square plus 1 plus square root of n square minus 1. So our xn is, if you have in the numerator, it is of the type a minus b into a plus b. In place of a, we have root of n square plus 1. In place of b, we have root of n square minus 1. So it is a minus b into a plus b. And what is a minus b into a plus b? It is a square minus b square. If you square, root will vanish. So you will get n square plus 1 minus of n square minus 1. So in the denominator, root of n square plus 1 plus root of n square minus 1. Now take limit as n tends to infinity, because our aim is to find whether this given sequence is convergent or divergent or oscillatory. So for that, you have to take the limit as n tends to infinity. In the numerator, what happens is plus 1 plus n square minus n square cancels. What is left is plus 1, that is 2 divided by. In the denominator, inside the root, you take n outside. Inside the root, you take n outside in both the terms. Both the terms implies root of n square plus 1 and root of n square minus 1. In both the terms, you take n square outside, but root of n square is what? Root of n square is n. So n is a common term for both the two terms. You will get n into root of 1 plus 1 by n square plus root of 1 minus 1 by n square. This is by taking n square inside the root outside. Next, that root of n square is being written as n. So what finally we will get a 2 by n into root of 1 plus 1 by n square plus root of 1 minus 1 by n square as n tends to infinity. So therefore, as n tends to infinity here, 1 by infinity is 0. Similarly here, 1 by infinity is 0. 1 plus 1 is what? 2. N is infinity here. So I will get 2 by infinity, root of 1 plus 1 by infinity, plus root of 1 minus 1 by infinity. Infinity square is nothing but infinity. This is 2 by infinity into root of 1 plus 0, plus root of 1 minus 0, because 1 by infinity is 0. So you will get whatsoever may be here. In the denominator, you have infinity. Therefore, 1 by infinity is nothing but 0. 1 by infinity is nothing but 0. So we have a finite limit here. Therefore, the given sequence xn, which is equal to root of n square plus 1 minus root of n square minus 1, is convergent because it converges to the limit 0. Next, we shall take another problem. That is the sequence xn, which is equal to 1 plus 2 square plus 2 power n. Our sequence is xn equals 1 plus 2 square plus so on up to 2 power n. It's a geometric sequence because it is of the form ar square, like that. So what is the formula for geometric series? A into 1 minus r power n divided by 1 minus r. A into 1 minus r power n divided by 1 minus r is the summation. What is our A? A is the first term. First term is what? 1. R, how do you get R? Any term divided by previous term. If we take 2, the previous term is 1. If we take 2 square, the previous term is 2. So if we take 2, the previous term is 1. 2 divided by 1, that is equal to 2. So R common ratio is 2. And what is the formula we have? A into 1 minus r power n divided by 1 minus r. Substitute the value of a and r here, you will get 1 minus 1 into 1 minus r is 2, 2 power n divided by 1 minus 2. In the denominator, you will get minus 1 because 1 minus 2 is minus 1. But there is one theorem. What is that theorem? Limit of x raised to n as n tends to infinity is infinity if the value of x is greater than 1. Limit of x power n as n tends to infinity is plus infinity if x is greater than 1. Here, what is our x? X is 2. 2 is greater than 1. 2 is greater than 1. Therefore, its limit is what? Plus infinity. So, therefore, 2 power n limit is plus infinity. Instead of 2, if you have half, it is 0, remember, limit is 0. But you have 2. But if you have 3, that is also infinity. If you have 4, that is also infinity because 4 is greater than 1. So we'll get 1 minus infinity by minus 1. So it is 1 minus infinity is infinity by minus 1, or you can say that infinity itself. So therefore it is divergent. So because the limit is infinity, hence the given sequence is divergent here. It is not convergent because it doesn't convert to a finite limit, but it diverges to a plus infinity. Let us take another problem. 1 square plus 2 square plus 3 square plus so on up to n square divided by n cube. Let us discuss the behavior of this sequence. So for that, let xn be equal to 1 square plus 2 square plus 3 square plus so on n square divided by n cube. Taking limit as n tends to infinity here, what we will get is the summation of squares of sum of the squares of n natural numbers is n into n plus 1 into 2n plus 1 divided by 6 into divided by n cube is there because in the denominator we have n cube. So it becomes a 6n cube as n tends to infinity. Take n outside in all these terms because of into, because they are the multiplication of terms here. You will get n into n into n. Therefore it is n cube into 1 plus 1 by n, 2 plus 1 by n by taking n outside in all these terms divided by 6n cube. N cube cancels. Now take n tends to infinity. You will get 1 by infinity is 0. 1 by infinity is 0 here also. 1 into 2 is 2. 2 by 6. 2 by 6 is nothing but 1 by 3. It's a finite, unique real number. Therefore, the given sequence is convergent. Because it's a finite, unique real number. Limit is a finite, unique real number. Hence, the given sequence is convergent. So these are all the problems on convergence and divergence of certain sequences. Let us move on to the next topic that is on this chapter. It may be the last topic of this chapter, infinite sequences. Cauchy's principle of convergence. So Cauchy's principle of convergence. So what it states is, let us have a definition. A sequence xn is said to satisfy Cauchy principle of convergence if for a given epsilon positive, however small, there exists a positive integer m such that modulus of xn plus p minus xn is less than epsilon for every n greater than or equal to m and p equals 1, 2, 3, so on. The meaning of this is, we say that a sequence xn satisfies the Cauchy's principle of convergence if you take any epsilon positive number, however big or however small, okay, there exists a positive integer m. There always exists a positive integer m, so that it should satisfy what? It should satisfy modulus of xn plus p. Remember, n plus p is greater than n for any natural number. For any natural number, n plus p is greater than n. If you take xn plus p, that is the term next to xn, remember, xn plus p minus xn, if you can make it less than positive number epsilon for some finite number of terms, that is for n greater than or equal to m, then we say that the given sequence xn satisfies Cauchy's principle of convergence. A sequence xn is called a Cauchy sequence. Let's have another definition. A sequence xn is called a Cauchy sequence if it satisfies Cauchy principle of convergence. The above definition is satisfied. First definition is satisfied. For any sequence xn, we say that the given sequence is Cauchy. So given sequence is Cauchy implies. In other words, a sequence xn is a Cauchy sequence implies it should satisfy Cauchy principle of convergence. In other words, modulus of xn plus p minus xn should be less than epsilon. Next, let us verify one problem now. Verify Cauchy's criterion for the sequence 1 by n. Let us verify the Cauchy's principle of convergence for the sequence 1 by n. We know that the limit of 1 by n as n tends to infinity is 0. Remember, remember that the sequence 1 by n is convergent because it converges to 0. Let xn be equal to 1 by n. But how do you write the limit in terms of epsilon? 1 by n, what is the definition of the limit? The difference between 1 by n, that is modulus of 1 by n minus 0, is less than epsilon by 2 for every n greater than or equal to m. This is the definition of the limit, remember. Limit of 1 by n as n tends to infinity 0 implies there always exists epsilon positive, such that modulus of 1 by n minus 0 is less than epsilon by 2 for each n greater than or equal to some positive integer m. Remember, small m is a positive integer. Now, for any value of p equals 1, 2, 3, 4, 5 like that, n plus p is greater than n. Is it true? Yes. Is 2 plus 1 greater than 2? Yes. Is 3 plus 1 greater than 3? Yes. Therefore, always it is true that because n and p are natural numbers, in case of natural numbers, n plus p is always greater than n for every p. Remember, this result holds modulus of 1 minus 0 less than epsilon by 2 for every n greater than or equal to m ಅಂದ್ರೆ ಅರ್ಥ ಏನು? m ಗಿಂತ ಈಕ್ವಲ್ ಅಥವಾ m ಗಿಂತ ಜಾಸ್ತಿ ಇರುವ ನಂಬರಿಗೆ ಈ ರಿಸಲ್ಟ್ ಹೋಲ್ಡ್ ಆಗುತ್ತೆ. ಯಾವ ರಿಸಲ್ಟ್? 1 by n minus 0 is less than epsilon by 2. ಇದರ ಅರ್ಥ ಏನು ಹೇಳಿ? m ಗಿಂತ ಜಾಸ್ತಿ ಇರುವ ಅಥವಾ m ಗೂ ಬರುತ್ತೆ, m ಗಿಂತ ಜಾಸ್ತಿ ಇರುವ ನಂಬರ್ ಯಾವುದೇ ತಗೊಂಡ್ರು ಈ ಮಾಡ್ಯುಲಸ್ ಆಫ್ 1 by n minus 0 is less than epsilon by 2. ಹಾಗಿದ್ರೆ n plus b ಗ್ರೇಟರ್ ದ್ಯಾನ್ n ಆದ್ರಿಂದ ಅಂದ್ರೆ n ಗಿಂತ ಜಾಸ್ತಿ ಇರುವ ನಂಬರ್ ಇದು, ಇದಕ್ಕೂ ಕೂಡ ಇದು ಬರಲೇಬೇಕು ತಾನೆ. ಯಾವುದು? ಈ ರಿಸಲ್ಟ್ ಹೋಲ್ಡ್ ಆಗಬೇಕು. ಈ ರಿಸಲ್ಟ್ ಹೋಲ್ಡ್ ಆಗಬೇಕು ಅಂದ್ರೆ n ರಿಪ್ಲೇಸ್ ಮಾಡಿ n plus p ಬರೆದಾಗ ಬರಲೇಬೇಕು. ಸೊ ಮಾಡ್ಯುಲಸ್ ಆಫ್ 1 by n plus p minus 0 is less than epsilon by 2. This is because n plus p is greater than n, but n is greater than m. Therefore, n plus p is greater than m. Remember, it is n plus p. So n plus p is greater than m. That is, now consider modulus of 1 by n plus p minus 1 by n. You take this one, modulus of 1 by n plus p minus 1 by n. You can write this as modulus of 1 by n plus p minus 0 minus 1 by n minus 0. Nothing has been changed here because adding 0 and subtracting 0, it doesn't vary. Adrinda ಇದನ್ನ ಹೀಗೆ ಬರೀಬಹುದು. ಬಟ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎ ಪ್ಲಸ್ ಬಿ ಇದ್ರೆ ಬರೆಯೋದು ಹೇಗೆ? ಒಂದು ರಿಸಲ್ಟ್ ಇದೆ. ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎ ಪ್ಲಸ್ ಬಿ ಇದ್ರೆ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎ ಪ್ಲಸ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಬಿ ಲೆಸ್ ದ್ಯಾನ್ ಆರ್ ಈಕ್ವಲ್ ಟು ಅಲ್ವಾ? ಲೆಸ್ ದ್ಯಾನ್ ಆರ್ ಈಕ್ವಲ್ ಟು ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎ ಪ್ಲಸ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಬಿ. Therefore, you can write this as this is less than or equal to modulus of 1 by n plus p minus 0, 1 by n plus p minus 0 plus 0 minus 1 by n. Remember, modulus of 1 minus 1 by n minus 0 andru onde, 0 minus 1 by n andru andre because of the modulus. But modulus of 1 by n plus p minus 0 is less than what? Illi barkondidire mele, it is less than epsilon by 2. And modulus of 1 by n minus 0 andru onde, 0 minus 1 by n andru onde. Modulus of 1 by n minus 0 is less than epsilon by 2. So epsilon by 2 plus epsilon by 2 is nothing but epsilon. So what we have is modulus of 1 by n plus p minus 1 by n is less than epsilon for every n greater than or equal to m. This is the definition. This is limit or convergent sequence definition. Therefore, modulus of xn plus p, xn plus p ಅಂದ್ರೆ n replace ಮಾಡಿ n plus p ಬರೆದ್ರೆ you will get 1 by n plus p. So xn plus p minus xn is less than epsilon for every n greater than or equal to m. Cauchy principle of convergence ಅದೇ ಅಲ್ವಾ? Modulus of xn plus p minus xn less than epsilon. ಅಲ್ಲಿಗೆ ಈ ಸೀಕ್ವೆನ್ಸ್ ಏನಾಯ್ತು? ಸೀಕ್ವೆನ್ಸ್ Cauchy's criterion satisfy ಮಾಡುತ್ತೆ ಅಂತ ಆಯ್ತು. So Cauchy's criterion is being satisfied by the given sequence. ಯಾವ ಸೀಕ್ವೆನ್ಸ್ ಇದು? This is sigma, this is the sequence 1 by n. Remember, this sequence is convergent. Adrinda, a very convergent sequence is always Cauchy. ಯಾವ sequence convergent ಆಗುತ್ತೋ, here it converges to 0. So ಯಾವ sequence convergent ಆಗುತ್ತೋ, that sequence is always Cauchy. That is the theorem next. So what the theorem is, every convergent sequence is Cauchy. Every convergent sequence is Cauchy. ಅಂದ್ರೆ ಒಂದು ಸೀಕ್ವೆನ್ಸ್ ಕನ್ವರ್ಜೆಂಟ್ ಆಗಿದ್ರೆ ಮೇಲ್ಗಡೆ ಪ್ರಾಬ್ಲಮ್ ಇದೆಯಲ್ಲ, sequence 1 by n, it converges to 0. ಆದ್ದರಿಂದ ಲಾಸ್ಟಿಗೆ ನಮ್ಗೆ ಏನು ಬಂದಿದೆ, ಇಟ್ ಈಸ್ satisfies Cauchy's criterion. Cauchy's criterion ಅಂದ್ರೆ Cauchy sequence. So every convergent sequence is Cauchy. So proof, let the sequence xn be convergent. So let the sequence xn be convergent. That is, limit of xn as n tends to infinity is 1, L. So I can say limit of xn as n tends to infinity, a finite real number, say L. What is the meaning of limit? Limit implies given epsilon positive or epsilon by 2 positive, because it is also a positive number, however small, there exists a positive integer capital N such that modulus of xn minus L is less than epsilon or epsilon by 2 for every n greater than or equal to n. This is the definition of the limit. What is the definition of the limit? Limit of xn as n tends to infinity is L. That is the definition of the limit. Therefore, using definition of the limit, you can write like this. But you know that n plus p is greater than n for every p, a natural number, because p value is 1, 2, 3, 4, 5 like that. So n plus p is greater than n, it's always true. Therefore, modulus of xn plus p minus L is less than epsilon by 2, because n ಗಿಂತ ಜಾಸ್ತಿ ಇರುವ ಎಲ್ಲ ನಂಬರಿಗೂ ಈ ರಿಸಲ್ಟ್ ಬರುತ್ತೆ ಅಂದಮೇಲೆ modulus of xn plus p minus L is less than epsilon by 2. Now consider modulus of xn minus xn plus p. You can write this as, ಸ್ವಲ್ಪ ಅಡ್ಜಸ್ಟ್ಮೆಂಟ್ ಮಾಡೋಣ. ಹೇಗೆ? ಪ್ಲಸ್ ಎಲ್ ಮೈನಸ್ ಎಲ್ ಅನ್ನು ಸೇರಿಸಿದ್ರೆ ವ್ಯಾಲ್ಯೂ ಏನು ಆಲ್ಟರ್ ಆಗಲ್ಲ, ಬಿಕಾಸ್ ಪ್ಲಸ್ ಎಲ್ ಮೈನಸ್ ಎಲ್ ಅಂದರೆ 0. ಸೊ ಐ ಕ್ಯಾನ್ ರೈಟ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ xn minus L plus L minus xn plus p. This is less than or equal to, ಯಾಕಂದ್ರೆ ಮಾಡ್ಯುಲಸ್ ಆಫ್ a plus b ಹೇಗೆ ಬರೀಬಹುದು? ಲೆಸ್ than or equal to mod a plus mod b, ಎರಡು ಮಾಡ್ಯುಲಸ್ ಆಗಿ ಬರೀಬಹುದು. ಹೇಗೆ? ಪ್ರೊವೈಡೆಡ್ ಇಲ್ಲಿ ಲೆಸ್ than or equal to ಬರೀಲೇಬೇಕು. ಸೊ ಲೆಸ್ than or equal to ಮಾಡ್ಯುಲಸ್ ಆಫ್ xn minus L plus modulus of xn plus p minus L. Remember, L minus xn plus p modulus ಅಂದ್ರೂ ಒಂದೇ, xn plus p minus L ಬರೆದ್ರು ಒಂದೇ, modulus ಇದ್ದಿದ್ರಿಂದ ಅದು ಪಾಸಿಟಿವ್. ಸೊ ದಿಸ್ ಇಸ್ ಲೆಸ್ ದ್ಯಾನ್ modulus of xn minus L ಇಲ್ಲೆಲ್ಲೋ ಬರ್ದಿದ್ರಿ, ಏನ್ ಬರ್ದಿದ್ರಿ? ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ ಎಪ್ಸಿಲಾನ್ ಬೈ 2. ಹಾಗೆ modulus of xn plus p minus L ಅದನ್ನು ಏನು ಬರ್ದಿದ್ರಿ? ಇಟ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ ಎಪ್ಸಿಲಾನ್ ಬೈ 2. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. ಲೆಸ್ ದ್ಯಾನ್ ಎಪ್ಸಿಲಾನ್ ಬೈ 2 plus less than epsilon by 2, it is epsilon. So what we have is xn minus of xn plus p, its modulus is less than epsilon for every n, not only n plus p, it is also greater than or equal to n. So it implies what? Idu yavadara definition idu yavadara definition andre beginning alli ಒಂದು definition ಬಂದಿದೆ. So x modulus of xn plus p minus xn is less than epsilon for every n greater than or equal to m andre the sequence, it is a Cauchy sequence. Cauchy sequence adrinda, so that is being satisfied. That is, the sequence xn is Cauchy. Andre first starting ಏನು ತಗೊಂಡಿದ್ರಿ? You have taken a convergent sequence. ಈಗ you are arrived at what? Every convergent sequence is Cauchy. Andre, so that is, you have proved the theorem. Every convergent sequence is Cauchy. Okay, this completes this chapter here, and you have a problem on Cauchy sequence also, that is 1 by n. You can take many problems like this, n plus 1 by n, instead of 1 by n, you can take n plus 1 by n, and so on. Okay, and but you have to take convergent sequences. If you take any convergent sequence, you can prove that on similar lines. ಇದೇ ರೀತಿ ಬರ್ಕೋತಾ ಹೋದ್ರೆ what you will get is, that is a Cauchy sequence. ಅಂದ್ರೆ ಸೇಮ್ xn plus p ತಗೊಳ್ಳಿ, ಹಾಗೆ xn ತಗೊಳ್ಳಿ, ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿ, and because of the convergence, so Cauchy's criterion is satisfied. So do you have any doubts? Yes or no? Some of them, someone should unmute and tell me. Yes, do you have any doubts? ಯಾರು ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ ಹೇಳಿ. ನೀವು ಇದೀರಾ ಇಲ್ವಾ ಅಂತಾರೋ ಗೊತ್ತಾಗುತ್ತೆ ಅದಕ್ಕಾಗಿ. ಎಸ್, ವೈಷ್ಣವಿ ಎನ್?
No, sir.
No. Yesterday you were absent. Why? ಬರಲೇ ಇಲ್ವಲ್ಲ ಕ್ಲಾಸಿಗೆ, ಅದಕ್ಕಾಗಿ ನಾನು ಮುಂದೆ ಹಾಕ್ಬೇಕಾಯ್ತು.
ಹಾ ಸರ್, ಬಂದಿದ್ದೆ ನಾನು, ಯಾರು ಇರ್ಲಿಲ್ಲ, ನಾನು ಒಬ್ಳೇ ಇದ್ದೆ ಅವಾಗ. ಸೊ ನಾನು ಎಕ್ಸಿಟ್ ಆದೆ.
ಹೌದಾ? Okay, right. Thank you. So I shall conclude my class now.